Welcome to my session on how we used OpenNebula at Departement Omgeving to allow our dev teams to go live faster. On the agenda today we have first a little introduction, then a little bit about the challenges we faced and how we came up with a solution to resolve those challenges. A little bit about me. I'm Lodewijk de Schuiter. I started working at Departement Omgeving in April 2015. Where I'm part of the middleware team, which creates, besides middleware applications, also the deployment automation, CI/CD, responsible for everything that has to do with application security, our Keycloak stack, which is one big part of it, and our cloud native stack, which mainly consists of a config server and a service registry. The Departement Omgeving is part of the Flemish government and is a merger in 2017 of the Department of Environment and the Department of Spatial Planning. The aim of the Department of Omgeving is to create an integrated environmental/planning policy. So for instance, if you apply for a permit, you have to both fulfill your environmental requirements and your planning requirements, otherwise you won't receive a permit. IT at Departement Omgeving. We have 5 dev teams which represent about 50 plus developers and 1 infra team / middleware which is about 7 full-time persons. We have 2 data centers, one in Aalst and one in Ghent, which are interconnected by a 10 gigabit fiber it's a layer 2 stretched network. We have about 1 petabyte of storage and 26 hypervisors. Most of our applications use Java and Spring Boot, and our open source applications, of which we have in total about 300 plus applications. Our database of choice is PostgreSQL server, and of which we run about 150 instances. Most of our applications are using an HA setup, which means that for the application server there are at least 2 nodes. We have 3 environments: the dev environment, which is used by our dev teams to run and test their features, a test environment which is used by the business to do user acceptance testing, and the prod environment, which is the actual live environment. Besides that, we also do hosting for befriended entities and agencies, which means that we run about a little over 2,200 virtual machines on our infrastructure. The challenges we had in the past was that we had a huge number of virtual machines which needed to be attended by a rather small infra team. The infrastructure was also very complex, to say the least. There was a lot of room for human error. There was little to no self-service for the dev teams, which means that if they wanted to do a deployment, they had to ask the infrastructure team, which quickly leads to capacity problems. There was also a lack of visibility that made it very difficult to assess what was happening in our environment. Because of this complex infrastructure and the lot of manual intervention, recovering after a disaster was rather small. So that meant that in 2016 we redesigned our hosting environment, and we went from hosting our VMs on VMware to hosting them on OpenNebula. For storage, we went from using Sun ZFS appliance to Ceph storage. From the one application, one VLAN strategy, we went to 10 plus functional VLANs. That also meant that we could get rid of our enterprise service bus we used as an application router, and we introduced a service registry in which applications can register themselves once they are available for other applications to be consumed. From manual configuration management, we went to a version-controlled configuration management by using our config server. And for monitoring, we introduced Zabbix for application and infrastructure monitoring. We also used the Spring Boot admin for managing our Spring Boot applications. And we also introduced an Elk stack for shipping our logs. And as a deployment philosophy, we applied infrastructure as code. This deployment philosophy means that we want to eliminate the manual intervention, and we automate the deployment of all our servers and the registration in the different external context. This means that there is less room for human error. There is also repeatability, because if you do a new deploy, you scratch the whole virtual machine and all its external systems, and we recreate the whole system from scratch. This also allows us to migrate servers easily between data centers, so that in case of a disaster, we can quickly recover in the other data center. Also, self-service for development teams, so that there's no intervention of the infrastructure team when they need to do a deployment. We made this possible by introducing our OHO server template, which stands for OpenNebula Hosting Omgeving or Environment. This server template is a simple YAML file which is in version control and is a description of your virtual machine, network, disk, RAM, CPU, etc. The external context: do you need DNS? Do you need backup? Do you need to be registered in monitoring? Do you need a load balancer? Do you need security and key cloak, etc. The software that needs to be installed, and also it's very easy to extend those YAML files with new infrastructure components that we introduce. These server templates are then used as input for our automation tool, which is in fact a two-step process. First, we generate from this YAML file a context file for each of the different targeted systems, and these context files are then used by our automation tool to provision the different external systems. On the next slide, we have a little diagram on how the deployment of a server or virtual machine actually goes. On the top swimming lane, you have the release server. In the middle swimming lane, you have the external systems that we want to provision. And on the lower swimming lane, we have the virtual machine, what happens on the virtual machine. The first step is that we read the template from version control and we generate the different context files. Once the different context files are generated, the deployment process is started by putting the servers in maintenance. We do that by contacting Zabbix to say that if there are problems with the server during deployment, they can be ignored. The next step is to create the data disk if they are not existing. Data disks are persistent between deploys. System disk, operating system disk are always scratched and recreated. For doing so, we connect to OpenNebula, which in its turn connects to Ceph to create the necessary block devices. Once the data disks are created, we create the virtual machine or recreate it if it's already existing. If it's already existing, OpenNebula sends a shutdown to the existing machine and also spins up a new virtual machine. The virtual machine starts and it fetches its config from our server config from our Cumuli config server. It installs the necessary software. The software starts, and one of the first steps is that it fetches its application config from the config server. And once it's started, it registers itself with a service registry so that other applications can start consuming the service provided by this virtual machine. In the meantime, the deployment of the server continues by registering, if it's needed, the server in a domain name server. Therefore, we do a REST call to our PowerDNS server. If the server needs to have internet access, we register this virtual machine in our forward proxy. Only the URLs that are configured in the server template can be visited by the virtual machine. So that means that there is no possibility for leaking information on the internet if it's not configured. If the server needs security, we can register it in Keycloak. Therefore, we connect the Keycloak cluster. If the server needs a load balancer, we register it in our F5 big IP load balancer, and then we wait a couple of minutes, 10. That we do because we mainly use Ubuntu as our host operating system for our virtual machines, and in Ubuntu you can only install one piece of software at a time. So that way we make sure that the software it's specified in our service templates is completely installed. So if the server needs monitoring after 10 minutes, we contact Zabbix to register the server in Zabbix, and we also install the Zabbix agents on our newly created virtual machine. The next step is, if the server needs a backup, we register the server in Bacula, which is our backup system, and we also install the backup client on our virtual machine. Once all that is done, the server is ready to be used by our dev teams or production. This whole process, we constructed a web UI for our development teams, in which they can do the deployment in the different environments. They also can do deployment in production. That means that they can go live in a matter of minutes, and by doing so they do over 500 deploys a week. Of course, that diagram describes the complete cycle for the deployment of a server, but as an infrastructure team, from time to time you want to do certain specific actions, and therefore we created also a command line interface which allows the infrastructure team to do specific tasks. For instance, only register the load balancer, only trigger DNS, etc. This solution we also use as a disaster recovery plan. We can easily spin up servers in the other data center automatically by restoring backups, and this means that we easily can manage over 2,200 virtual machines. And this whole solution made our dev team and our infrastructure happier, so that we can focus on more important things and move our environment to the future. So that was it for my presentation. I'm happy to answer all the questions that you may have in the Q&A. Thank you.